Okay, this is my pre-calculus. What's my sine and cosine lab number 9? I've done a video already 1 through 8, so I'm going to do these bigger word problems, just one video per each. So this one says a population of animals oscillates between a low of 1,300 on January 1st, when time is 0, and a high of 2,200 on July 1st, when time is 6. Sketch a graph of the function for a 2-year period, find the formula, interpret the amplitude period in midline, and find algebraically what 2 months in each year the population is 1,500. So let's start with A. We're going to sketch the graph. And when I sketch the graph, we're going to make it kind of large here. They want 2 years, so let's do 2 years. So we're going to make a nice graph. You have your whole paper here, so let's just do the whole thing here. And this is time in months. And this is my population, and it's the number of animals, okay? And I'm going to go through, and remember, it's our graph, so the low is 1,300, so that's going to be here. I get to pick. The high is 2,200. I get to pick. And we're going to go for 2 years. So January 1st is going to be our 0, and then the next one is going to be July 1st. Then January 1st, then July 1st, then January 1st. So I'm kind of, they want us to do 2 years. Oops, January 1st. I don't know why I put a 7 there. January 1st. Okay. Then we're going to go through and just kind of sketch what this looked like. So it's a low of 1,300, and then on July 1st, it's up to 2,200. A low of 1,300 back in January, a high of 2,200, and then a low again here. So I'm going to erase this right here. And then we're going to go through and just sketch it. It's not perfect, but it kind of looks like that. So I sketched the function. Now it said it's trigonometric, so we're going to find what the formula would be. And the formula, we always do the same thing each time. For B, we're going to say looks like amplitude, frequency, period, and midline. So as I look at this, it looks like it's starting low, then high. So this definitely looks like a negative cosine curve. My midline is high, which is 2,200, plus my low, 1,300, divided by 2. So it's going to be y equals 1,750. And I always come up and make sure that that's kind of in the middle. And 1,750 is here. So y equals 1,750. Okay. Now I'm going to come here. My amplitude is my high, which is 2,200, minus my 1,750. So I get 450. My period for one curve is still 1 year, even though this is in months. So I'm going to say 12 equals 2 pi over my frequency. We've done this so many times. And if I cross multiply or switch these places, you get 2 pi over 6, 2 pi over 12, which is pi over 6. Okay, so now I have a nice population equation. So the population equation would be negative 450 cosine. Okay, then I've got pi over 6t plus 1750. All right, so now this is a modeling of the information that they just gave us, which is really cool, I think. Also, sometimes I wanted to let you know, sometimes they put the midline up front, so you might see it p equals 1750 minus 450. You see that a lot, especially when it's been an inverted cosine curve. Okay? So the C part, what does the C part ask us? Well, the C part says, interpret the amplitude, period, and midline of this function, okay? And so the amplitude, if we're talking about animals, is really the difference between the high and the low, it's really the difference of the average. The amplitude, okay, is the high and the low about the average. And the average is your midline. So the average population we said was 1750. So the amplitude, it goes up 450, down 450. So it's like the variation between the mean or the average. Okay, that's what amplitude is. The period, how would we say that for this? Well, the period is one full cycle of our curve, and our curve is the high and the low. So it's basically, you could also say it's one full cycle of the season. So the period is one full cycle of the year. You could say seasons as well, where you see what happens throughout one whole year. Okay, so we talked about amplitude, we talked about what period is. Midline is basically the average population. Is average population. So I know that what you know in graph, but I want you to be able to talk about it as what does it mean in real world. Okay. The D part asks us, okay, find algebraically what 2 months in which the population is 1,500. So let's come up here and look at our graph first. So 1,500, so if this is 1,750 right here, and this is our graph, 1,500 is going to be, we'll say here. So 1,500 would come here. So I'm just going to look at the one cycle. So you're looking here and here. You're trying to figure out, okay, when is my population 1,500 according to our model? So that's what you do is you're going to put it actually equal, your population equal to 1,500 minus 450 cosine pi over 6t plus 1750. And then you're going to do some normal math first to get it so we can do the inverse. So I'm going to subtract 1750 on both sides first. When I do, I get negative 250 equals negative 450 cosine pi over 6t. And then because the negative 450 is hooked to the cosine by multiplication, we're going to divide both sides by 450. And when I divide both sides by negative 450, it comes out, it turns positive. So I end up getting a 5/9 for a fraction equals the cosine of pi over 6t. So we're good so far. Now, the only way that we can undo this to solve the month is we're going to hit our inverse cosine. So we're going to undo both sides. Thanks for playing. So I have the inverse cosine of 5/9, which you're not familiar with, so you're going to have to use your calculator. You got to make sure you're in radians as well, equals pi over 6t. And if I want to solve for t, I'm going to multiply both sides by the reciprocal. So my time is 6 over pi times the inverse cosine of 5/9. And please make sure you're in radians. When you do, you get this wonderful decimal of 1.87503. So I'm going to round it to about 1.88. So the 2 times this is going to happen is, so if we look at our graph here, if 0 is 1, 1, all right, so 1.88 you're talking about is going to be February. Okay, so this is going to be February sometime that this is going to happen. And then when I subtract 12 minus 1.88, because we're trying to find the other time of the year this happens, and the other time of the year it happens is going to be in the fall somewhere, or maybe near the winter. So you're going to do 12 minus 0.188, which is 10.12, and that's going to be roughly around November. And the reason why it seems weird, okay, so there's 2 ways it'll happen, November and February, is because we let January 1st be 0. So you have to remember, okay, that means February is 1, March is 2. So when you do 10.12, that is November. So you're talking in November and in February is when the population of these animals are 1,500. So I hope this helps.